Okay, everything is fine. So, let's talk about square root decomposition. I think that's my title. Yeah. Okay. So, we can do range queries in root n. This is a whole array and we're dividing it into multiple blocks. Okay. Um, so, okay. Okay, so we have this array. Okay, we're dividing it into multiple blocks, right? Of size, let's say B, and number of blocks we're going to have is total elements upon B. Okay, and we definitely need like the seal value. Okay, maybe this is fine. Now this is fine, I believe. Yeah. Okay. Now, what will be the time complexity if we are, let's say, finding addition? So we will store values like, okay. So there is going to be another, so this is a 2D array, right? It is gonna store these things, and there will be another array which will be of size, n upon b. Okay, which will be of this size, and we are going to store like the value for the whole block. So if we're querying for sum, then we're gonna store like sum of all elements. Yeah. For maximum minimum, we can store maximum and minimum. We can also do GCD. Yeah, we can perform all like almost all the things that we do with segment tree. So what will be the time complexity? So if we have some range, so if we have something like this, okay. So okay, so if we have something like this, then we will have to check for like this whole block size. So it is going to be B. Similarly for this side, another B, and the number of blocks, which is simply, let's call this n minus n upon b for now. Okay, it's like almost n upon b, right? Okay, so this is 2b plus n upon b, and now we have to minimize this. Okay, so minimize this for the block size. So let's differentiate this with b. We will have 2 here, and n is constant, and b to the power minus 1 is b to the power minus 2. So this will be b square. Okay, let's put this equals to 0. So by the way, do we really care about this? Let's keep it. Okay, and we have n upon b squared, so this is going to be negative of n upon b squared. Okay, we have something negative. Well, this is equals to 0, so finding derivative for this. That should be equals to 0. This is a derivative. And okay, so n is equals to what? We have -2 into b square. Okay. Now we can send like so v square is basically n by 2, right? It's negative of n by 2. Well, this is always going to be positive, so why do we have negative sign here? Is there any mistake? Hello. Do we have any negative sign? This will always be positive. Why do we have like negative? We have 2 plus. But I can see like this is coming out to be root n. So that makes sense. But we have a negative sign. Why do we have a negative sign? This is a function. This is the derivative. Oh, my bad. This is... Okay, so derivative is going to be -2 upon this thing. Okay, now we good. So we have 2 here. We can cancel out 2. And we also now have positive sign. So we don't have 2 here. So yeah, so b is basically root n. So if the block size is root n, our time complexity is going to be minimum. So how do we implement this? Okay. Let's see how can we solve fourth problem. Yeah, so we have queries. We can add value to every element. We have to compute these pairs. This is limited. We need square root decomposition on this nums too. So what do we need essentially? We need to find how many values are equal to this. Right? So how many values inside this block is equal to some number a. So for that, we can store like a frequency table. So we can build frequency table for each block and for each element, right? So again, we need 2 frequency tables here, right? And what will we do? We will see these overlapping ranges. Here we can query with the block frequency table, and here we can query using these frequency table. Okay, we can query each element. We can see if this is equal to some. Okay. Well, we don't even need the frequency table for each one of them. We just need for blocks. Right? We can see whether the element is equal to that or not. Okay, that makes sense. So frequency for this block will be how many elements are equal to this. And we will be using, we can use our array as well. right? Okay, so okay, so let's implement this. Okay, let's use namespace std. It's called main function, and we are going to let's build like a normal template so that I can use it later on as well, and then we will solve that specific problem with it. That's a cool idea. So we're going to make this array equals to okay, we will see whether the queries are working or not working. Fine, let's create a structure. What should be named? Square root decomposition. Square root. I think that's a big name, but that's fine. Okay. What do we need here? So we need a vector. I'll call this blocks. We also need another vector. This is going to be a 2D one. Okay. And let's call this ARR only. Let's call this yeah. We also need a value for n, and we also need b, which is a block size. Okay, let's quickly make a constructor. So we are going to have let's take a whole vector here. Okay, v dot size. Then what we can do, we can find the square root. Now I should think about indices a bit. So if we have, let's say, a block of size 11, under root of square root of 11 will give me something like 3 3 9, right? So it will give me like it will give me 3. But how many blocks we actually need? Wait, so if size is 3, then we will have like 3 2 6, 3 3 9, 10 11 12. Okay, so we are going to have like 4 blocks. So we need seal values to see like how many blocks we need. So I think we're good, right? Should we take like 4? Should we go for 3 or 4? 4 2 8. I think both are going to work. There is going to be no difference. So I can either choose to go with 3 or 4. Okay. So let's go with right. Then we can see. This is fine. Okay. We also need like we also have to see how many blocks we have. Okay. So blocks is going to be n plus b minus 1 upon b. Okay, I think this is fine. Now let's initialize a vector. We will also have to build it. We can make a build function and do it. I think that is going to be much better option. Or we can also build it here if we want. What should I do? Let's make a build function. Okay, it's also going to take same vector. We will have a vector and we are going to build it. But here we are making sure that everything is cool. Also, let's assign sizes. Okay, so ARR dot assign. What are we going to? So it is going to be of size B, which is like the number of blocks that we have. Right? Then in a specific block, it is going to be of size B. Okay, and we're putting, let's say, 0, right? I will override this. And then we have block ARR. Size of this is going to be number of blocks we have. I think let's also assign this as 0. Okay. I have to think about indexing. How will I get indices? So if we have some element at some index I, we need to figure out in which block that element will be and also at which particular index. Okay. So I think block is just, I will just divide it. So if we have something like this, so this belongs to, so we have something like this. This is the structure that we have. Okay. So if we have some element here, which block it belongs to, we just need like a floor value. Okay. So we can, like, if we have, let's say 3, we can divide it by number of blocks. How many blocks do we have here? Wait, this should be divided by block size. Let's do a +1 because of 0 indexing, and then the size of the block. Okay, yeah, so size of the block is 3 only. This is fine. What if we have 5 here? Then we will get 2. So this is not good. 0 1 2. This is going to give me 0. Okay. Okay, this is fine. 3 will give me 1. Okay. So this is how get okay, so which block? That is basically index upon size of block. What is the size? Upon B. And which block? Now we need like which IDX inside a block. That we can decide by. So we have a specific number of elements. That depends on remainder. Okay. So that depends on I mod B. So if we have 4, what is 4 mod 3? 4 mod 3 is going to give me 1. Okay. Let's talk about this one. 6. Also, in that scenario, we are going to have 0 here, which I don't want. Or maybe if we have addition, I can do the 0 thing. I can also do something like this. So in my case, I will probably assign some negative value. No? Okay, now I can build this. Let's also create functions. So get block, right? So we will have some index and we are going to return I upon B. Okay, and inside a block, so get idx, that is going to be I mod B. Okay, so we good. What's the issue? It works like um okay, so now we can do this, but we will have to call this like for an every element. But while we are building, we don't have to do it. We can optimize, but let's not, let's go with this method only. I think that is fine. Hi Pritam, what are you learning? Where is this used? So it's square root decomposition. This technique is very similar to segmentary. We can use it for like range queries, for like addition, min, max, etc. But there are few cases where implementing segmentary is very hard. For example, this problem. So if you know like how to implement square root decomposition, you can solve this problem like easily. But if you will think of in terms of segmentary, then it is going to be a bit harder. I'm not even sure whether this problem can be solved using segmentary. But thinking in this, like thinking like this, these blocks, it's very easy to solve it in n root n. This is why I'm learning this technique. Also, like by looking at the constraint, you should think about root n solution. So yeah. Also, I'm not looking at code from CP algorithms. I'm coding it myself. Right. So what do I need? So let's insert value in this ARR. So get block of I, and then here we have get idx. I could have done this like without a function, but that's okay. Okay, this is equals to what? B of I. Okay, so this thing is done, like array will be created. Okay, yeah, so it's always good to know these multiple techniques because there are problem where you cannot use one and you can use other ones. So this is why I'm kind of learning this. But like the idea is very simple. I believe segmentary might be like harder to understand than this. Also, code is also straightforward, so I think it's better to know this one. But building this block is going to be a bit tedious because, so first of all, I can always use a while loop to do this. I can get like which block added to block. Should I solve my problem or should I like, let's build it for addition. Let's build it for addition, okay? So inside this block, block ARR of index is going to be get block of I. So at this index, we can add B of I. Okay. This is fine, I believe. In this block, do this. I think this is fine. But if we're building for addition, we should make sure we have zeros here. Okay. I think query is going to be a bit tedious. Okay, let's see. Get sum. Okay. So we have some range, LR. We need sum from that range. We're going to return integer. Okay. Now how will be query? Okay. Now to query this table, we need to find like three things. First of all, this leftover. To find this thing, this leftover thing, until this index. Okay. How can we do that? We can get which block and which index. All right. If index equals to 0, or maybe some other thing I can use. We could also have a like a perfect query. Should I like do this manually and then okay. So we know which block and which index. So I can process this block and then I can keep going to other blocks until we see the last one. So okay. So this A and B. So let's call these A and B. Okay. I think that is a good idea. Okay. So A is going to be get block for this L. And B is going to be get block for this R. Okay. So we know which block we are starting and which block we're ending to. Now we are going to run a for loop. So let's use long. Initialize it at 0. Now let's use a for loop. It will start from A plus 1. Okay, so I should be less than B. We won't go till B. I think that is fine. So what do we need? We need this block ARR of this I. We need to add it to our sum. And now let's process the leftovers. Okay. So to process leftovers, we also need let's do it like that. So we know which block. Okay, blocks are A and B. So we know the block index. We can get index for IDX, and until it is less than B, we can process. I think that is fine. So I need to get index. Okay, so I equals to get index for L. That is fine. It should be less than B. That is also fine. And there will be another loop which is going to start from 0 and it will go till get IDX for R, and it will go till that IDX. Okay. Yeah, perfect. We can add this sum for our ARR. We know this is the 8th block. Okay. That's also okay. And we also know like this is R block. This is B block. Okay. I think we are done. Now we can return this sum. Okay, I think this is cool. Anything else I need? I don't think so. Let's try to use this. So let's create an object of this. What should I name it? I don't know. Okay, let's call this object. Let's also pass on ARR in the constructor. Also called build inside the constructor so that it builds everything. Okay, fine. Now we can query. So what was the name of the function? So get sum, and absolutely inside this obj. So this is not a pointer, we can use dot, right? Now we have to pass on L to R. So let's try 2, 4. Let's try more. Let's try 0, 4. Let's try, there are I think 11 objects. Let's try 5, 5. Let's try 7, 8. What is the edge cases? 0. There are 11 or 12 elements. I'm not sure. There are 11 elements. So this index is going to be 10. Let's also. Okay. Let's see the output. Is this working or not working? It's building. Well, I don't think this is working. Is there anything wrong? Oops. Holy shit. Build and run goes to run dot out. Run dot out, but it's not taking input output. So this is fine. Run dot out. Is there any issue with it? Is there any issue like with me not using? Should I define my that was not a problem. What could be the issue? It's also building in background. These are just snippets. Why do I have this? How can I duplicate scene? Oh, what am I looking at? What? Holy shit, I don't want that. Okay, my stream is fine, so. but I'm not getting any output. So what is the name of the file? It's called main.cpp out. Let's call this app. I think that's all I need. Okay, some issues. Some issue in allocation. This size failed. Which thing failed? Okay. Okay, so there is a error. It's not even showing me error here. This is why. There is some vector issue here. Maybe this indices issue or something like that. But like this cannot be greater than, this cannot be B, right? We are good. This is good. This is for L, this is for R. So um let's see if that is the problem. Nope, that is not a problem. The problem is somewhere else. Maybe here. Exactly. So this is wrong. So get block. B is a block size. So we always have like more blocks. How this can be wrong? Website running? My website running? Are you asking for my projects or something? Okay, this is the issue. I mean, B of I is, what is this N? Wait a minute. Oh, okay. Okay. Okay, now this is fine. We have 3, 7, so this is wrong. We should not have 3. So I'm getting block and adding this V of I. Okay, so this is 3. Should be 10. Why is this wrong? Let's see like some here, then okay, let's not print this. Let's just call it for now. Also, this is returning something, right? That's okay now. Expected what? We have 003. We have 003. 2, 4. Okay. Let's see like what's the problem. So this is the array, and what is going to be square root? So n is equals to the 11 elements, right? Yeah. So n is 11. Square root, I think this is going to give me, at least this should give me, what if 3 3s are 9? Okay, that is fine. Okay, so b is 3, and n is basically 11 plus 3, like 14 minus 1, 13 upon 3. So it is like 4. We need 4 blocks. Okay. Let me see whether this is okay or not. So size of this is blocks. I can access this right outside as well. Let's see everything outside then. Okay. So before doing any of that, okay, I is less than obj dot blocks. This is a variable, and we will have to block ARR of I. That is it. That's okay. Let's see what is this block ARR. Holy shit! Why the size is blocks ARR? Assign blocks. Holy shit. I mean, it's still wrong, but okay, what is a block ARR? It's 14 for this. Why is this 14? It should not be 14. Do you have any? Acha, old question. It should not be 14, right? This is 3. That is cool. 11 is also fine. 3 is also fine. Oh, 14 है, ठीक तो है. Okay, block भी ठीक है. Block is also fine. This should also be fine then. Let's see what is ARR. Let's use auto. We have ARR inside, and let's take values inside this iterator. Let's see out every value. Space. Let's also print end line. So we have 437 210083 120. That is fine. Okay. So these two things are fine now. Something must be wrong here. Let's add C out. Let's see. If we will do like 0,4. Okay. We have 7 plus 4. Wait a minute. So if we have something like this, what will happen? So first block is going to be 0. Okay. So 0 get block. So this is going to give me 0. And for right one, this is going to give me 4. So 4 by 3 is, wait, cat block is correct. 4 by 3 is 1. So this should be good. Apparently this is 0, 4. Okay. This gives me 1, which is fine. But okay. This must be 0, which is the case. So we're getting index A and B. So what is going on? We are getting 4 from here. And this itself is wrong, like completely wrong. This is not 4. This is going to be, this should be 14 here. Get index of L. L is 0. What is 0 mod B? Is 0 mod any number is like, what? What is 0 mod X? Should be, read says 0 modulus X. So this is 0, assuming X is a non-zero number. Okay. So we're starting from 0, we're going till B, we're adding everything. But this is still 4. This is 0. If this is 0, then this is, oh my god, this B is having issues. Okay. Let's call them X and Y. This is apparently X. We don't have by anywhere. What is this thing here? It should be less than by. Okay. This should also be X and Y. Okay. Okay. Now this is correct. I mean, the code itself was correct. It was just like variable names. Now I can run this and hopefully this is going to give me correct answer. Okay, so we have 21. What is 5 comma 5 is 3. Do we have C out anywhere else? Well, not really. So again, this is wrong then. What is 5 comma 5? Should be 0, but saying it's 3. 10 comma 10 is also 5, which is wrong. Let's see, why is this wrong? So 5 by 3 is going to give me it should be here, like in a first block, right? It should be in a first block. So we have this thing, and another 5 is also here. So both numbers are same basically. X is also same, y is also same. That's what's happening. This will not execute. We get index, this will be 2. We will add it, fine. But here this is X. Both are same numbers. But how am I getting 3? This is the whole block. Okay. What the fuck is going on? Makes sense. Okay, so we have 033. We have 003. Okay, so these two are fine, but we're going for a whole block here, which actually should not be the case. That's the issue. And this is gonna happen if we are like under a same block. How to fix this? This loop is, I think this is very concrete loop. I don't have to worry about this one. This is also pretty much concrete, I would say. This starting point is a little bit fucked up. What if x equals to y? This is the only case when x and y are equal, I believe. Right? Because if they are different, if blocks are different, this code is going to be valid. Also, is this cool if we are in a same block? This is also not good. Starting index is fine, but ending index should be like I should add something. Okay, so if x equals to y, Then I will add some loop here. How will I get the endpoint? The endpoint is going to be get IDX for R, I believe. Should be equal to that. And we have this sum. And we can return it, right? Let's put it over here only. Okay. This is good now. What is 10, 10? Perfect. What is 0, 10? Let's take a easy one. Oh. We're getting some error. Why? Holy shit. From here or somewhere else? The error is somewhere here. I wish it's not. There's some issue here. Block ARR should be less than by. Maybe this is our issue. This can also like not exceed. Is my input wrong? Like, yeah, my input is wrong. That's why I'm getting wrong answer. Okay. 0, 2, 3 says 6. 6 is the max. Let's analyze their output. I also don't need this. Okay, good. I'm getting 1, which is fine. This is 4, which is also fine. This must be 2, and then 2, 5 is 4. Let's see some problem. Square root decomposition problem. CSES. How are they doing it? Okay, so starting block is going to be L upon block size. That's how I'm doing it. Okay, same concept, same concept. Wait, if starting block equals to end block, then going from L to R. Oh, then you're just going through indices? What? And you're just adding ARR. Oh, okay. Makes sense, makes sense. I think my code is correct now. I have not implemented an update function. Let's also do that. But while updating, I will also have to maintain it. Let's do a range update function. So it is going to be void, and it will be range update. Similar, we have L to R. I believe I can copy like code. And we can modify this. Okay, so things are okay. We don't need some. Okay, so in range update, we will have to update like a specific ARR, and we will also have to. If both are same, then what I'll do? What is a range update? Setting some value or like increasing value by some number or decreasing by some number? That depends on a problem. Let's see, we are increasing number. Okay, we can also query and do it. But let's say we are increasing this. So we also have a value. So this whole thing, it's getting increased by this value. We can return here if that is the scenario. Okay, but we will also have to update. So if we are increasing, we can just add. So we know like which particular block. So blocks are same. So we can go to block ARR. So both are same, and I'm going to add this value to it because we are adding it. So in a whole block, and this is good. Let's talk about blocks. So I will not be updating every single value. Also, there is also something I'm missing. Okay. So here I'm just going to update this block. Okay. 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 Something I'm missing here in the get sum is that I should also. So if I'm adding some values, nope. So in case of blocks, I'm just grabbing some from the blocks, else I'm grabbing some from this ARR. So I just need to make sure this block sum is fine. And also values are also fine. But how will I update values? This is a problem. Square root decomposition. We can perform updates. But how? So we have a block sum. So what I'm saying is that the sum of this whole block has been increased by this number. Okay. So that whenever I'll go here, that doesn't make any sense. We will have block sum. God damn. Okay. So wait a minute. Okay, so here I'm updating both things. So block sum is maintained here, block sum is maintained here, but values are not maintained. Okay, block sum is always maintained. mm, what should we do here? Should we make another array and we should just say that this whole block value has been increased by this number, and then when we are iterating we can always use that. I think we can do something like that. Mm, I should basically, let's go to range queries. Okay, there we go. Some queries. Will this accept and root n solution? This is 10 to the power 5. Let's see. So given an integer array of an integer, proceed q queries in a form. What is the sum of value in this range? So we don't have updates here. We have this input. We have to print these output for queries. I believe this is size of the array and this is number of queries. Okay, this is what I want to do. Increase each value in this range by u. What is the value at position k? So this is not range query. What is the value at this position? Well, value at this position. Um, static range. What I'm doing here, this should be value into b, which is a block size. So now this is good. Should I use? Should I use one more array for proper range update and some queries? Um, or is it possible with the current setup? Yeah, lazy array, we need it. which is a pending addition per block. This line is the problem. You updated only the block sum, not the actual elements inside this block. Exactly. Later when a query arrives, which still contain old values, so you need another structure. You cannot simultaneously support efficient range updates and efficient range sum queries. Let's create another array. So I think we need this shit again. Let's call this lazy. And let's assign this lazy 0. Okay. What should we do here now? Wait, let's think properly. So this is the problem right now. Okay. This does not update element inside it. What I will do, I will increase. So I need like size of the block. I don't need like, okay. I think I'll be fine with this. And I will be updating lazy of I. Okay. So this is telling me like all the value inside this block should be like, okay, let's do plus here. Should sum up by this number. So whenever I'm querying, I need to make sure. But this might again cause some problem. Lazy updates. This is fine. Here I'm not adding lazy, okay? Because values are getting updated. I'm doing lazy here because only block size is getting updated. So we also know like all values inside this block should sum up or should sum up by this number if we are like querying them one by one. Right, block size is always maintained. Now in sum, if I'm querying this element, I should also sum up lazy. This element and this lazy of X. Okay, here should be have lazy of Y. I think this is good now. Okay, let's ask GPT. Is this good? Is this good? Almost. It's correct. Now the one important bug. When you do partial update on boundary blocks, you forgot those elements are logically because the blocks may already have pending lazy additions. Yeah. So partial updates. Oh, so when I'm doing block updates, partial update. Okay, this is the thing. So it should be value plus lazy. And we can make lazy 0 here. Right, because we have already added it. Right. I think this is a cool template. Let's call lazy of y. Let's make it 0. Let's add this value and let's add lazy as well. Let's update the block first, then call lazy. Okay. Not yet. Now the logic. This line is wrong. Okay. To all elements of the block once. Not every time you touch an element. Wait, I don't get it. So what am I doing here? Oh, this is the total sum. So I'm updating block. But um so we don't need lazy here because we are updating value. Okay, we need lazy here. I'm only storing like for the block how much I need to increase. I don't know. Mm, mm. So lazy is storing like the sum of this whole block has been increased by 5. Okay, so all the elements, if I'm traversing all the elements inside that block, I'm going to add it. Something like this. Okay. In this block and I'm adding it. Right. If we are going for block, then block is maintained perfectly. We don't have to do anything here. Okay. Okay, wait. This is fine. Okay. Whole block size increased. Okay, so whole size of this block I is going to be into B. We are just adding this value to it. Fine. Now we are here at the individual element. Okay. We are summing these individual elements by this lazy of X. It is fine, right? Because every element is increasing, so but making it 0 doesn't make any sense then. Okay. Array of X and I increased by value, also increasing block size. Don't hallucinate. Oh my god. It is gonna hallucinate by deciphering my spelling. Return in, but you compute long sum. That is okay. I can do that straight away. Yeah. Does not handle the case where a boundary block already has a pending lazy. Okay. So we could have a case where a boundary block does not have lazy, does have pending lazy updates. Lazy x by is non-zero, and you do a partial update on that block. The state becomes inconsistent until you push the lazy first. Correct for fully converted blocks. That stays true only if every update path keeps block array synchronized with lazy and partial sums correctly. That is cool. I just need to fix my lazy. Boundary block already has pending updates. So we are increasing this value, but I was right. It should be like this, no? This block is always maintained, okay? But if I'm doing this update, then I don't have to. I don't understand this. I don't have to update it. Is non-zero. If so, y is non-zero, you do partial update on that block. The state becomes inconsistent unless you push the lazy first. I don't know what that means. Suppose a block originally is lazy is 5. Meaning the real values are logically this. Okay, fine. But physically, array is still this and you do partial updates add 2 to index 0 only. So your code does this, so physically array becomes like this. Lazy is still 5, which is fine. Another partial update or propagation, you no longer know whether AR or FI already contain lazy or it doesn't. Lol. Logical value, so array is now this. Lazy is 5. Let you decide to propagate lazy. Why would I fucking propagate lazy? I won't do it. Now, what the fuck? You said that my code is wrong. Blah, blah, blah. This is for range updates and range some queries. ChatGPT is so shit. Oh my god. How do I disable this thing? Holy shit. You have correctly implemented the core mechanics with lazy full block updates. However, there are few minor issues. Optimizations, okay. Integer overflow risk. Get some function correctly returns long, but your block array lazy vectors are defined as int. In your range updates, you have this line. If value is large, b is reasonably large, then this will easily overflow. Division by 0 case, so n could be 0 in that case, but that is not going to be the case. I mean, that's fine. Cache locality 2D versus 1D, or isn't 2D array to represent blocks while correctness logically correct vectors of vector poor cache. Just use standard of size n. You already have a great helper function, so you don't actually need a 2D grid. The exact index in a 1D array. Oh, wait, what? I don't need this. Oops. Okay, this is of size n. Acha, makes sense. So this is basically equal to V now. I don't have to change anything. Okay. Makes sense, makes sense. Could have done that. This will also like save some memory. Okay, so where I'm using this ARR. Here I can simply do like I, right? But I'm doing like get ITX. But then I don't have to do this in get ITX. I can start from L and go till R. Okay. Also have this. So this is a block number. Again, I am playing with I get IDX. I think we are good. I'm not going to overcomplicate this. This is update, right? I believe that is fine. Maybe I can do this. The first input let's take NQ. Let's take both of them. And let's create this vector of size n. Okay. ARR of I. We have vector, now we also have multiple queries, I believe. Um, four queries. Okay. We only have like a single query. What is the sum value of range a comma b? So we only have two things here, L and R. And we just have to like see out obj dot get sum from L to R. Is the indexing fine? It's going from 1 to n. Okay, let's also do minus minus R. So I think this code is good. I need to submit file. Submit main.cpp. cp main.cpp. There we go. Should run. No. Okay. Outputs are long, I believe. So let's do long. Oh, that's not, might be the issue. User output. So these are big outputs. What is the issue with the assign? Okay. Anything else I can change? This value is under int, I believe. Yeah, everything is under integer, but now I think it should be fine if my code is correct. Okay, accepted. Let's try update queries. Increase each value in this range by u. And what is the value at position k? What is the value of at position k? So we have two type of updates now. That depends on the first query. Okay, so we have n and q. This is the array we are taking it. Then let's process queries. Let's see what is the first number. So let's take x. Okay. Now if x equals to 1, then we have to take three integers. We have AB is a range, I believe, and yeah, AB and V. Let's take all of them. And then obj dot, it's called range update. Go from A to B. We will have to increase each value. Okay, that should be fine. Else we have two things. I think that is correct. Okay. Oh, we only have a single number, k. Let's do something. Let's call this get range sum. If we need a point sum, let's create new function. Here. Yeah, get sum. So this is an index that we have. Let's call this L. And now we can simply return So we have to see like we need to also return like lazy updates. So we will cat block. Okay, which block this value lie, and then get idx. Okay, this thing plus lazy of get block. I think that is fine. Right? Now I can use this get some. Okay, let's submit this. Okay, this is correct. So my implementation is correct. Okay, now let's solve this problem. So here we don't need sum, we need frequency of elements. Add value to every element. So addition thing is same. What will I do with like addition thing? If I'm adding 2, I can use lazy here to see like what is the target that I actually need. Okay. Okay, let's think about it. So I definitely need lazy because for updates, well, this block is going to change. Okay, I don't need some of the block, right? But I'm storing some of the block now. Wait a minute. Let's add things to this. I want a query like this particular number is present how many number of times. Maintaining frequency is good, but how will I update? I can go to frequency, like, so frequency of this block, and that particular element will decrease, and then that particular element plus value will increase. Okay, so let's do let's create a vector. This vector will have an unordered map. This will map our frequency. So this, I will call it like a frequency map. Okay, so very similar to this, but I think we need it as well. Let's talk about range updates. But first of all, let's build it. Okay. So how do we build it? We will call this frequency. We will get this block. Okay. Now in this block, we will say this number is plus plus. Okay. So in that particular block, this number is coming once. Fine. Okay. Let's go to updates now. So we have range and we are adding values to it. So in this case, what I will do. So I'm inside like a single block, simple block. I will reduce what was the value before and I'll increase it. Right. Okay. So block is X. This is the value right now. This is the current value. Let's decrease it. And once it is updated, let's increase it. Okay, so this is maintained here too. How will I play with lazy though? Let's align with lazy. Okay, so this is fine. Now we are updating blocks. So here we will grab like from the lazy. That is also fine. We will see what we can do in the query. So here lazy is not getting updated. Here also lazy is not getting updated. So okay. That is also fine. That is also fine. The block is by. Okay. Cool. I think update is fine now. Let's go to. I have to create another function. Okay. Okay. So what? So it will return me like frequency. Get frequency. Let's see. Get frequency, and I will have like what? I will have a target. So this is my target. Now this target will be. No. I will have to go through every block. Okay. Every single block. I did not assign size for this, so let's call this frequency. Dot assign but what should be inside? It's just an empty. I don't know. Is that it should be empty? Oh, that works. Okay. So what will we do? My actual target is what? So okay. Hi Harshit. Harshit Chamoli. Oh, what up? Okay, so we will probably so we have lazy for like a specific block, and if we have incremented the value, we need to search for learning from best. Yes sir. क्या हाल है? एग्जाम कैसे जा रहे हैं भाई? मेरा कल ही एग्जाम है, मुझे भी पढ़ना पड़ेगा। अभी तक कुछ नहीं पढ़ा मैंने, खोल के भी नहीं देखा। रात में पढ़ूंगा। So that is going to be target minus lazy of I. Okay, because actual value is greater. If we're looking for 5, actual value is 8. Oh my god. Okay, so if this is the actual value, if lazy is let's say 2. That means actual values are 777. If my target is, let's say, 5, then I should look for what? I should look for 3, right? Target minus lazy. Because if this is 3, then this is 5. Okay, this is fine, I think. Let's assign count as 0. And let's take this count as, let's take frequency of I. And then we can see like how many times this X. Let's return the count. I think this is a good template. We can use it. आज तो ठीक गया. अच्छा आज था क्या? I hope that works. Okay, let's just see. It might be wrong. There might be some changes I have to do. We have square root decomposition. Okay, did I just copy something? Come on, paste. Let's create this object of square root decomposition, and we're gonna pass nums2 to it. Now, okay, so this will be built. Okay, let's update. So we go to this obj dot the range update function. Okay, so we're gonna range update this x comma by with this particular value. Fine, but here we have to do few things. So this is the target that we have. So int count, it should be object dot get frequency. I think this was the name of my function, I believe. dot. So I have to okay, I need a loop inside here. Okay, let's see, this count is 0, and I'm gonna loop to nums1. Then what is my target? Okay, so I need to make equals to tot. So this is going to be tot minus v. This is what I need now. Now I will go to this object and I will ask for the frequency of target, and once I'll get something in return, I will just add it to my count. Fine. Now I can push back this count here. I think, let's see. Okay. We're getting wrong answer. Something must be wrong. Okay, so we have nums2 as 3, 4 and query is 2, 5. So first we are updating. No, we're not updating, we're querying. Okay, so query is wrong actually. No updates, but like queries are wrong. Okay, so I believe lazy of I is going to give me 0 here. That is fine, right? So we're finding target. So at this block, how many elements are equal to target? So that should be correct. Mm, that should be correct. So while building, we know like this particular block, go here, and this is the value that we have, and just do a plus plus. नहीं करा भाई, मैं ये करके जा रहा हूँ एक्चुअली, टाइम हो गया आज का POTD, आई डोंट नो क्या था. आई थिंक दिस क्वेश्चन इज बेटर देन दैट. V of I. Yeah, I think this should be correct. No, I should see like what is the current frequency so that I can. I is less than obj dot b plus plus I. Let's see out the values. So that is called what? So in this block, how many elements exist of this frequency? Okay. So nums, we have size as 2. Square root of 2, we will have I think let's check. Okay, this frequency does not exist outside, so okay. Coming out to be 0. So we're checking by whether there is a 1 or not and saying 0. Okay. But why? So there is only one block. You only have one block. What is square root of 2? Square root of 2 will give me 1. So we have a single block. Wait a minute, what? But I should get like 1 here, no? Like there are like 2 blocks. Okay, something is wrong. So we are assigning the size of blocks. This is empty, so I believe this should be fine. Right, no issue with this. Hmm. Well, what are blocks? So we have 2 plus 1. So we have 2 upon 1. So there should be like 2 blocks. But how many blocks do we have? We have 2 blocks. No, that is okay. That is okay. So we're getting the block. So we are at like, so B is 1. Mod 1 will like return whatever we have. So mod 1 will always return us 0. Wait, what? This is size of a block. So this will give us 0 and 1 should give us 1 upon 1 will give us 1. This get block. I don't know why is this not working. I did plus plus. This should be fine. Let me check. Shit. Queries are 2,5. Why are queries 2,5? Wait a minute. Acha, this is a type of a query. Size is 2, then I'm just considering 5. So that is my target, which is 5. Cool. We have 1, 1 in both of the blocks, which should be the case. Oops, my bad. Holy shit. I'm so stupid. So we should have like 1, 0. So we have 3. And then we have 4 in a second block. Fine. So this is fine. Frequency is fine. So we are going to nums 1, which is, so what is TOT? TOT is 5. So this is what we need. So we're searching for 4 here. Okay. Let's see what is the count. How do I? We are increasing this. Let's do this res and let's print end line. I think the 1 zeros are coming from here. So we have 0 and 1. So 4 we have 0, which is correct. Wait, 4 is not 0. We have 4 here. So is my lazy correctly initialized? I'm going. Oh my god. Holy shit. Now we should. Okay. Now this is correct, but others. This one is also. Let's check this one out. We have like zeros only because we only have 2 and 3s. So block size is 3 here. Square root of 3 is also, I mean, it's okay. So we have 2, 2. So this is working like fine at least. Oh, this first output is okay, but after update, this is not fine. So we go to like 0 to 1. So these two numbers and we'll increase them by 1. So we have 333 now. Okay. We are increasing block size here. We will be increasing block size, no? Yep. So number is not getting increased. Oh my god. Okay. But I'm adding like this value to lazy. So I know like which amount this number is increasing. So we have like 333 now. And now if I query, I should get 6. I have not updated frequency array. I don't have to update frequency array, right? Oh, what do I mean by checking 4? So we have 1, 1, 2, 3, and we have 1, we have 1, 2, 3. Okay, that makes sense. We should have lazy, right? We should, so this should execute here. If this is not executing, then I mean this is executing. This is also fine, right? I'm updating the values, decreasing the frequency by 1. Then I'm increasing the value, and I'm increasing the frequency by 1. But I believe like X and Y are not same, so. But like I should get 0 if I'm trying to do something here. God, shit. Okay, let's try to debug this one. We only have a single request. Let's check out whether lazy is even getting executed or not. Okay, so we see what is like X and Y. Also, let's remove all the print options. Don't need them for now. Okay, so where are we? So what is X and Y? Okay, so 0 and 1, which is fine. So this will not execute. Hence, this will be executed. This will go to 1 and it should be less than 1 and it should be less than 1. This won't be executed. Then this will be executed. Okay. Less than block size. Block size is 1. This should be 0. This should be executed at least once. Okay. See out. What is the frequency of? Okay. This one and this one too. Here we have Y, so oh, my update is wrong. Oh, there we go. This must be Y. Yep. I think that was the issue. I found it. I fixed it. Excuse me. Not really. Oh, I'm also getting a negative number. That is not very cool. If I'm decreasing, I should make sure that that frequency. Okay, updates are fucked up. I'm decreasing this, but this is fine, no? So I'm getting -1 here. Okay. Wait, I'm getting negative frequency. Should be plus plus. Now everything is fine. We can submit this and this is going to work. Right. All right, not very efficient. I believe I should probably. Do I need this array? No, actually don't. I need lazy. I need frequency. I need this block. Do I need this block? Wait a minute, let me think. Do I need this? So I'm already like every single frequency, and in range update, decrementing frequency, I don't need this block here. Absolutely useless to me. Also don't need this block here. Also don't need this block here because we have lazy. We don't need block, we don't need ARR. We need ARR, right? We need values. Maybe we can convert them into 1D array. That is going to be a bit efficient. I think I should. It's time. So let's see like CPL go. Now check this one. This is basic. Yeah, same thing. This is an implementation. Okay, this also this is a correct one, right? I'll probably, should I? Let's post this template, okay, so that I can use it. I don't need this. Okay, this is my own. Wait a minute. Let me remove all the frequency code. Maybe I have a better option. Where are RMQs? So range update queries. Go to my code. Yeah, there we go. But like this was point update. I believe range updates are also going to be fine. So let's also ask once like, what the fuck is that, bro? Holy shit. Oh. Final check, please. Imagine writing code like this. Oh my god. All right. I will also need to look at Moose algorithm. I think that is also cool. I'll do it later on. So square root decomposition. Okay. Pasting everything. I believe. How do I usually paste my code? Yeah. So basically, I have a class. That's it. And I can import and use it. Okay. 99% on the way. Update the internal arrays. There are 2 strict tiny left in the version. Wrong answer. Your range update function still have val defined as int. That is okay. Division by 0 crash if n is 0. That is also fine. This is optional. I should do this then push, because I don't have like a very good feeling about it. So maybe okay. Let's convert this into 1D array. Okay, let's do this. ARR equals to V. Wait, what I'm doing? Yep, this is equals to V. This ARR is basically vector of integers. Now we are good. It's updating blocks. Now get some. This is for point updates, I believe. So we can just update L. We don't need anything else. Yeah. Plus we will get whatever the block is. Fine. We are here at range sum. I can start from L and go to R if that's the case. L to R, I think that is good. Okay. That is also fine. We don't need it here, but let's fix this one too. So we have we're starting from some index and we're updating lazy as well. Here also I can, so we're starting from L and we're going till B. So what I should be doing here? Okay, so we can maybe start from L. That is correct always. I can only go till that particular block. So how many indices do I have left? Get IDX is going to give me the index and I don't know. Wait a minute. So these indices we should know actually. So we should know like which index I have started, which is going to be my ending index. So what is my ending index here? Ending index is going to be L plus B by wait, what? L plus B by B. I have no idea. What the fuck? Wait. Okay. So I need the particular index where the block ends. How to find the index? What is I upon B? What is I upon B? If this is a query, let's say, what is 1 upon? How to get upper bound for this? So first I know like which block and which block I am. So I can get it like get blocks. So I know like this is the block that I'm editing, that I'm doing this thing. Okay, so that is just X. So that is the particular block. What is going to be like the upper ceiling of this? That is going to be this multiplied by. So if Over here we know like this is size is 3, right? B is 3, so we know this is like X is 0. Fuck. We can do like next block -1, so I think this is going to be X plus 1 into B. This is first block, so if I do like 1 into 3, I'll get this starting point, and I need ending point here. That is fine, actually, that is fine. Less than sign is there. Now how to do this? So we will start from this block. To get a starting index, I will do the same thing. This is a starting index, but this is not X plus 1, right? This is, what's going to be the starting point? So we have R, which is a number of block. So this is going to be 2. This is perfect. Okay, and then we should go till should be less than or equals to R. Okay, fine. Let's also fix this. Fine. I'll make similar changes here as well. So this is fine. Here we can do like similar thing. So I start from L and I go till B into, what was that? X plus 1 into B. Okay. What was X? Holy shit, this is wrong. It should be L. Okay. This should be L plus 1, same thing, into B, should be less than that. It will start from R into B. This is starting index, and it will go till R. Also, we could here too. I believe, yep. Is there anything? Check this one. Let's also do a summation so that we know it's correct. Okay, let's check this one out. Okay. What compile error? Oh fuck. There is some position. Wait, I did not update it here. What? But like, I might have forgot to remove this, I believe. I think everything else is correct. Okay. Compilation error, out of bounds. Oh my. Runtime error. Okay, it's going out of bounds. So fix is, it should be L and then should be X plus 1 by B. It should be X only. Array, I did fuck. X was correct because X is like a block. Okay. That is the only one, right? Value in, that is okay. I don't know why I'm emphasizing this much, but that's fine. This is incorrect. Maybe we got this too far. आवाज बहुत कम आ रही है यार. I guess. हेलो. ठीक है भाई. Okay. Confusing the array index with block index. Okay. So, what is this R? This shouldn't be R, right? This should be Y. Then this is fine. That is the only problem here, I believe. That is the only issue. Please. Again. What's wrong now? Holy shit. Oh my god. We are using range update and get some. So this value and the particular block. But something is still wrong, right? हाँ. Code is still breaking, right? Feedback incorrect. Correct on line 1. Expected this and got this. Alright, so okay. Why does that happen? Oh my god, I don't want to debug this. First is correct, second, third, fourth. This was expected and this is what I got. Y into B, and it should be less than equals to R. Y into B. Y is the block. We have LR. Okay, we have LR. Starting from ending here. And this is going to be the next block. X plus 1 into B. And we can only go like till before. This is also correct. So things are correct, like almost. I don't know why. X by L to R and L to R. So pi lazy X. I have no idea. Why is that happening? Wait, is this integer? Oh my god, this was the problem. This is the problem. Okay, now it will work. Okay. Okay. Come on. We good, we good, we good. Yeah. Let's push this one. Okay. All right. So there we go. Okay, I think I'm done. Okay.